Hello everyone, my name is Zihi Wang, and my partner is Azizo. Today we'd like to present for Project 141, Who Killed the Somerton Man. It is supervised by Professor Derek Abbott and Dr. Andrew Allison. In December 1st, 1948, a man was found mysteriously dead on Somerton Beach, Adelaide, South Australia. His identity remains unknown until this day, and the case has been classified as one of Australia's biggest unsolved mysteries. Our project aims to investigate the Somerton Man's DNA with other sample DNA files via computer technicals and biological engineering methods. The Somerton Man's DNA was extracted from his hair sample, which has been kept in police museum. Unfortunately, the man has dead for more than half century, and therefore the hair has been degraded and his DNA data has been corrupted. Before presenting our outcome, I'd like to introduce some background knowledge. First is DNA. DNA is the hereditary material which stores the genetic information in humans. It is a molecule composed of two chains, while each chain is formed as four chemical bases or nucleotides, which are adenine, guanine, cytosine, and thymine. And the chromosome is an integrated package of DNA molecules. There are 23 pairs of chromosomes in human body's cell. We only used the first 22 pairs of chromosomes in the project. SMP or SNP are most common type of genetic variation among human beings. It is a variation of base pairs at a specific position in a DNA sequence. As an example, most individuals could have a base pair of CGs in specific positions in DNA sequence, but some individuals may have a base pair of TA instead of CG at that position. This means that there is a SMP in that specific position, and these variations could affect humans' personal characteristics such as genetic diseases or hair color. And here shows a screenshot of Somerton Man's DNA reference file. The file records a set of SMPs, and there are 4 columns used to identify these SMPs. First column RSID is the ID for identify each SMP. Chromosome identified which chromosome that SMP belongs to, and position indicate positions of SMPs in owner's DNA sequence. And genotype represents the base pairs of variants. If a symbol of double bars presented in genotype column, that means that the base pairs of this SMP is not determined, and we call it empty SMP. And only the non-empty SMPs can be used for DNA analysis. Our aim is to find who the Somerton Man is. To achieve that, we will firstly evaluate the robustness of Somerton Man's DNA, then try to identify any possible diseases and physical characteristics of the Somerton Man. Also, we are trying to find his relatives, and hopefully we can finally identify who he is. So our first task is to evaluate the quality of the Somerton Man's DNA reference file, and then try to conduct DNA examination on it. The evaluation was done by C++ program developed by us, and the DNA analysis services we used were provided by GenMatch. GenMatch is a website that has public personal genomic database and provide tools for DNA and genealogy research. Several tools we used are listed here. First one is one-to-many DNA comparison tool, which is used to find related DNA kits in the database. Eurogen tool is used for ethnicity examination. In addition, the website would require the uploaded DNA reference file has at least 2000 SNPs in each chromosome to conduct the DNA match services. And here is our outcome. As the table shown, there are more than 0.6 million SNPs in the Somerton Man's DNA file, but only about 2% of them are not empty. This is far worse than we expected. Such low quality of DNA data was rejected by GenMatch to conduct DNA match tests, which brings us to the task 2. The second task is to artificially recover Somerton Man's DNA so that it can be accepted by GenMatch to conduct the DNA matches service. The recovery work was done by our own developed C++ program. The program would replace certain amount of empty SNPs with selected base pairs. We have implemented several recovery algorithms, including filling empty SNPs with random base pairs or homozygous pairs, such as AA, GG, CC, or TT. The features here shows us 2 screenshots of DNA data that replace the empty SNPs with random pairs and fill the empty SNPs with base pair AA. As a result, there was no DNA kit found in the database related to Somerton Man's DNA files. We firstly recovered the file to 2000 SNPs in each chromosome, and the result was 0. And then we tried to recover more and more SNPs, but until we recover all the empty SNPs, the result still remains 0. So as a conclusion, for a low-quality DNA reference file, it is nearly impossible to find any related DNA kit in GenMatch database, and simple recovery strategies cannot help to improve the match results. But although the DNA examination was failed, but we still got ethnicity tests to work with. In task 3, we would conduct an ethnicity check on Somerton Man's DNA data, and this examination do not have minimum requirements for the amount of SNPs. Also, we would try to prove that the ethnicity report of low-quality DNA kit is reliable. The ethnicity examination tool we used was Eurogen ADMix utilities. The model selected was Eurogen K13, since this model provides certain ethnicity regions for report and is commonly used for European. To find out the reliability of poor quality DNA's ethnicity report, the project obtained 2 complete DNA samples which contain more than 95% non-empty SNPs in the files, and degrade them to different levels. The degradation process is to remove a certain amount of SNPs from original files. Degraded files of 10%, 20%, and until to 90% SNPs removed were generated by our C++ program. Also, extra files that got only 2.08% SNPs remained for each samples are provided. Then we would conduct ethnicity examinations on these files and observe how the measure ethnicity proportion changes via degradation process. we introduce 4 different algorithms. The first and second is for every 10 SMPs, we will remove first or last n% SMPs, where n is the percentage of SMPs we like to remove. And for last 2, we will remove first or last n% of SMPs in each chromosome. Here is the ethnicity report of the Somerton Man's DNA kit. As we can see, the largest ethnicity proportion is North Atlantic region, and the map of it is shown in the bottom right figure. And the second largest region is Baltic region. The map for it has been presented in the figure at the top right. Both regions are in Europe. Then we got the ethnicity reports for 2 complete DNA samples and their degraded version. The top 2 figures are the reports for DNA sample 1, and the bottom 2 are for sample 2. The left is the original files, ethnicity reports, and the right reports are for degraded files. As we can see, there is no obvious change on the major ethnicity proportions after the DNA samples have been degraded to Somerton Man's DNA level. This provides some evidence to support the Somerton Man's ethnicity report is somehow reliable. To further prove our theory, we also made this line graph. The y-axis present proportion of major ethnicity regions in the reports, and the x-axis show how much percentage of SMPs were removed from original files. The blue and orange line stands for the top 2 largest ethnicity regions of sample 1, and the gray and yellow one are for the sample 2. According to the graph, the percentage of major ethnicity regions would not be greatly affected by the amount of SMPs removed. These results provide a strong evidence that the proportion of major ethnicity regions in poor quality DNA kit is similar to the complete DNA kit. Then it comes to the last task. We will work on search any genetic diseases associated with Somerton Man's DNA. This task used a public genetic database called DBSMP. The database provides an API that allows the user to input RSID of a SMP and send back the relevant genetic information about the input SMP, which include the clinical effects in JSON format. And our Python program will extract these information and records the corresponding clinical information. So here is a screenshot of information provided by DBSMP, and due to time limits, I won't introduce it. As a result, we got about 574 genetic diseases associated with Somerton Man's remaining DNA. Unfortunately, there is no result strongly supports the man's known characteristics, such as hair color or enlarged spleen. And as a conclusion in general, the quality of Somerton Man's DNA is far poorer than we thought, which is about 2% out of 0.6 million SMPs available for DNA analysis. Such low quality DNA cannot be accepted for the DNA match services, and by implementing several algorithms to recover the DNA cannot help to find any related DNA kits in the database. But we somehow proved that the Somerton Man comes from Europe and his major ethnicity is North Atlantic and Baltic, and we found 574 genetic diseases that the man could possibly have, although none of these diseases is related to his known characteristic. Therefore, we cannot find who the Somerton Man is, and his identity will remain as a mystery. About future work, I would suggest to develop a better and more reliable strategy to recover the man's DNA. Since for such poor quality DNA there is not much analysis can be conducted. As we found his ethnicity, we can fill the empty SNPs with common SNPs among the Europeans. And that's all. Thanks for listening and watching.